Taiichi Ohno refers to Kanban as the Toyota Production System's operating method. I think of it as one of the greatest inventions ever. This is not only Kanban but lean production, the follow-on to mass production. There are a few reasons that Toyota was able to reach 6 Plus Sigma, but no reason was more important than Kanban. Kanban is Toyota's method of implementing pull. Kanban allows Toyota to operate with minimal excess inventory. It also allows Toyota to make their manufacturing line so flexible that it can make one product at a time. Let's look at how it works. This slide depicts a small part of an assembly line that is adding 3 components to a car. Each component contains a buffer of parts needed for succeeding cars. For example, the first component added to the cars are motors. The buffer contains 4 motors for possibly 4 different cars. The arrow shows that car 9 Kanban card has been added to the buffer. The middle buffer, steering, is more efficient than the first buffer in that it is a buffer of 3 versus the motor buffer of 4. Ideally, there would be no buffer. The steering example would have car 5 steering show up exactly when car 5 shows up. The next 4 slides are put in to show the progression of the buffer adding its components to the cars as they move along the assembly line. In each case, whether it's the back seats, steering, or motors, the Kanban system does not know what car 7's back seat will be until back seat 2 is deployed. The Kanban system transitions as follows. In this example, the cars have progressed forward, which causes the Kanban buffer to also move forward. If you remember the previous example, the back seats were about to be added to cart 2. Now the Kanban card for the third car is at the bottom of the buffer. Each of the buffers for steering and motors progressed forward 1 step. Now on to the next example. In this example, car 1 has rolled off the screen to the next station, and all the other cars have moved up 1 step. The backseat buffer has already deployed the backseat for car 3 and is now populated with the backseat for car 4. The steering assembly has also been deployed in car 6, so now the one for car 7 is ready, and car 9 has been added to its queue. This also shows a progression. The motor in car 9 has been deployed, so the Kanban car for car 13's motor has been pulled. I want to make another point here. Every manufacturer should know the length of their queues. Even if you bottle water and you need labels, how many labels do you have in the queue? Kanban also allows Toyota to stress their system. For example, you see that there are 5 back seats in the buffer. You could stress the system by removing one of the Kanban cards from the buffer. That would mean that in this example, car 7 back seat would be the last back seat in the queue. The advantage would be paying for 1 less back seat in the inventory. Example 5 is the last in the series. Again, the cars and the buffers have advanced. Each car contains a Kanban card that defines the specific motor, steering, and back seat that it needs. This allows Toyota to know the progression of each car's assembly and understand how much excess inventory it is holding at any one time. Now let's discuss some examples of queues. These 2 examples of queues I found on Google Earth. The first queue is of material used to produce steel, which you can see is on both sides of the road, and the second queue is of material used to build cement. The point here is that every manufacturing business has queues, whether you have knowledge about it or not. Toyota managed their supply queues such that they get a delivery every 2 hours. 2 hours is enough time for them to receive the supplies, sort the supplies, and start the movement of the supplies to the assembly line, and then consume the supplies. I want to make some points about the steel plant queue. The supplies you see here are just part of the story. They have even more supplies sitting on barges in the river and more storage across the river. This particular supply could be delivered on rail or ship. Of course, it would make no sense for a ship to show up every 2 hours. However, there is an optimal delivery schedule. The cement plant management seems to believe that the risk-cost ratio is best when they have maximized their material inventory. Their loads are most likely delivered by truck. Efficient truck delivery is much easier to execute than efficient ship delivery. However, if I was operating either of these plants, I would collect this sort of information to become more efficient. 1. What is the frequency of delivery? How much material do I have left over when I get a new delivery? How much does the size of delivery impact the cost? What delivery schedule is the supplier capable of executing? What is the minimal delivery size the supplier can deliver? How reliable is the supplier? Can I improve the reliability of the supplier? Are any of these supplies introduced at a point of flow? Are my processes standardized? And what is the state of production leveling? Answers to these questions lead to areas of process improvement. Also, any of these areas could be benefited by Toyota's continuous improvement program. Let's discuss the content of a Kanban card. The goal of a Kanban card is to transfer information. The contents of the Kanban card are specific to each system's needs. I've given you a list of 9 examples and also a demonstration of 2 Kanban cards. The bottom Kanban card example controls the input of parts to Toyota from a steel plant. This Kanban card is separated into 3 categories: origination information, information regarding the product, and destination information. This Kanban card represents a lot of work. It not only means that Toyota operates on a Kanban system, but that their suppliers do also. Since Toyota completed their Kanban initiative in 1962, many of their suppliers have also come on board. In Lean Six Sigma, there is an acronym that is used that highlights the breadth of waste. Waste is simply the things that are done in a system that a customer does not want to pay for. The acronym is downtimes, and the I stands for inventory. Though inventory is a waste, it is also used strategically in the Toyota production system. As lean production replaces mass production, the production line becomes lean and flexible. Whether your product is complex or simple, you should always know the cost of the inventory lined up to support its production. It is always important to stress your system. Kanban allows you to selectively remove Kanban cards and test whether the system can handle the new stress or not. Toyota designed Kanban while they were building it over a 12-year period. Today it should be quicker, but it will not be fast. Requirements are vision and stick-to-itiveness. This is a key competitive advantage of the Toyota production system. I am Jim Fitzgerald, a Lean Six Sigma Master Black Belt and expert on the Toyota production system. The road to 6+ Sigma has a sequence and has a velocity. The velocity is adjustable, but the sequence is somewhat fixed. At my website, www.buildyourtps.com, I expand out the very high-level steps from 7 to roughly 25 to 35 high-level steps.